Hello everyone. The title of this video is Evaluate Logarithmic Functions. Every exercise I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 10.3 titled Evaluate and Graph Logarithmic Functions, and I'll be working under the heading Evaluate Logarithmic Functions. I'll only be working on the even numbered exercises. Alright, these are the ones that don't have a link to the solution. All the odd numbered problems have a link to the solution that you can click on. Alright, so I'll be working on exercises 154, 156, 158, 160, all the way until 176. Alright. And I will have timestamps for when each of these exercises begins in the description of the video below. Alright, so example 1's timestamp will be for number 154, example 2 for number 156, example 3 for 158, and so on. Alright. And I also request that whenever I start a new question, pause the video and try to work it out yourself first before watching me doing it, and then compare. Because if you're just watching me do these things and not practicing yourself, chances are you're not learning all that much. Alright, so in this first set of exercises, we're given a logarithmic statement, an equation in logarithmic form, and we're asked to find the value of x in each equation. Right. So number 154 I have written out. Alright, so it's example 1, number 154 from the text. And we're given this equation. The logarithm with a base x of 49 equals 2. Alright, so before I get into actually solving this here, we have to remember some stuff from a previous video on logarithms. Remember, when you see the log base b of some number n, what that's equal to is the exponent. Right? Logarithms are equal to exponents. It's equal to the exponent. You would have to raise the base to, right? This was called the base of the logarithm, this little number under the log, the subscript. The log base b of n is equal to the exponent you would have to raise b to in order to get n, right? In order to get the number inside the logarithm. All right. And noting this, we also talked about in a previous video how to change, back and forth between exponential form, which I'll call exp, and logarithmic form, or just log. Right? If b to the p for power, if b to the p was equal to n, that meant exactly the same thing as the log base b of n was equal to p. Right? So I hope you keep all this stuff in mind from the last video I made on converting between logarithmic and exponential form. Keep that stuff in mind while I go through these questions here. Oh, and one other thing. When we're dealing with logarithms, the base must be a positive number, because some wacky stuff happens in functions where bases are negative. So that's also something we need to keep in mind. the base of the logarithm, this subscript must be a positive real number. Okay. No negative bases. Just like when we talked about exponential functions, right? We only looked at graphs of exponential functions with positive bases as well. Alright, so keeping all this stuff in mind, let's work. Alright, so number 1, exercise 154 again. Log base x of 49 equals 2. Now you might be able to already tell that the answer is 7, because 7 to the second power is 49. Now, if you don't recognize that, one way to get around this, one way to solve for x here is to change to exponential form. So exponential form, the equivalent statement to this would be x to the second power equals 49, and then you use the square root, solve this, right? Solve this quadratic equation. Using the square root property, we'd see that either x is 7 or x is negative 7, and then plug those back into the original equation. Remember, x equals 7 is fine, right? The log base 7 of 49 is 2. 7 squared is 49. That works. Now, negative 7 squared is also 49, but remember I said over here, the base, the number that's the subscript of the log, must be a positive number, so we are not going to be using negative bases, so that's an extraneous solution there. Alright, so the only solution to this equation, the only value of x that I'm going to consider working is x equals 7. Alright. Next question. Same, pretty similar to number 1. We have the log base x of 27 equals 3. So again, you can probably say, hey, x got to be 3, right? 3 to the third power is 27. But say you didn't see that. Change this from logarithmic form to exponential form. That'd be x to the third power equals 27. Right? And then we can solve this equation, by taking the cube root of both sides. X would be equal to 3. Right? And check it. Again, the log base 3 of 27 is 3, right? 3 to the third power is 27. That does work. And it's a positive number, right? A positive base. So that's great. Alright, next question. The variable is not in the base of the logarithm, but it's in the input of the logarithm, or what's called the argument of the logarithm, right? It's inside the log. So we have log base 3 of x equals 4. It's very simple. Again, I'm just taking all these. Basically, I'm doing the same thing every time. I'm taking these and changing to exponential form to get at that variable. And the exponential form of this, would be 3 to the fourth power equals x. And there we go. It's solved. X equals, 3 to the fourth power is fine, but 3 to the fourth power is 81. And then check it. Is the log base 3 of 81 equal to 4? Yeah, 3 to the fourth power is 81. That definitely works out. Great. All right, question 4, exercise 160 from the text. Very similar to 3, where the variable x is inside the logarithm, right, in the argument of the log, the input. So let me change this to exponential form to get it out of a logarithm. And that would be 2 to the negative 6 power equals x. And there it's solved for. X equals, 2 to the negative 6. Now remember, 2 to the negative 6 is the reciprocal of 2 to the positive 6. Right? So it's positive 1/64. X is positive 1/64 here. And that would work, I promise you. I'll leave it to you to check it. Alright, number 5. Now here x is already solved for. X is already solved for. So you gotta think 1/4 to what power? 1/4 to the x power is 1/16. Well, that's just x equals 2. Alright, 1/4 squared. Right? Since 1/4 to the second power is 1/16, right? And 2 is the variable. Right? 2, that works. Now, you could have also changed this to exponential form as well, and had 1/4 to the x power equals 1/16, and then tried solving this like I've solved exponential equations in a previous video using the one-to-one property, where you get both sides with the same base. You know, this is 1/4 to the x equals, and then 1/16 is 1/4 squared, and then it's obvious that x equals 2. Right? You know, because again, based on that one-to-one property of exponential functions, two expressions with the same base are only equal if their exponents are equal. So x must be equal to 2. So that would be an alternate way to find it. But x equals 2 there. All right, number 6. Same thing. You know, you could probably tell me what this is already. You know, 1/4 to what power is 64? All right, well, 1/4 to the negative third power is 64. So x equals -3. Right? It's only because 64 is a nice power of 1/4. But, you know, if you don't see that right away, you could, you know, change to exponential form, which would be 1/4 to the x power equals 64. And then you might think, oh, I know how to write both sides in a base of 4. You know, 1/4 is actually 4 to the -1. Right? That's the same thing as 1/4. And then that, you know, to the x power equals, and then 64 is 4 to the third power. Right? 4 times 4 times 4. And then here I need to use some properties of exponents to get a single power here. 4 to the negative first to the x would be 4 to the negative x power equals 4 to the third power, and then I apply that one-to-one property. The only way two expressions with the same base are equal is if their exponents are equal. So negative x must be equal to 3, and then dividing both sides by -1 gives me x must be -3. Right? So yeah, so you can do, you know, all these by changing to exponential form first, and then going about finding the value of x. And then, of course, checking your solution. Great. All right, so now in the next exercises, we are asked to find the exact value of each logarithm without using a calculator. So remember what this means. You know, number 7 here, it says the log base 7 of 49. Remember what this is equal to. What a logarithm is equal to. It's equal to an exponent. It's equal to a number. And it's an exponent that you would raise 7 to get 49. Exponent to raise 7 to get 49. Alright, so the log base 7 of 49 must be 2. Right, and that's because if you were to change to exponential form, right, since 7 to the second power is 49. Right? and that works. Now, an alternate way you could do this is say, I'm trying to find the log base 7 of 49, and you don't know what it's equal to. Yeah. So call it something. Say the log base 7 of 49 is x. And then this question becomes just like questions 6 and 5 that I did in this video. You can then change to exponential form. 7 to what power? 7 to the x power equals 49, and then up both sides are easily written in base 7. Right, 7 to the x equals 7 squared, and up x must be 2 then. Right? So, the log base 7 of 49 must be 2. Alright, now I know they said don't use a calculator, but I just want to doubly show you that this is correct. Now I have a TI-84 simulator, TI-83 emulator, 83, 84 are all the same, very much the same. Now there's a log base 10 button, right? That's not log base 7. There's this LN button, remember this was log base E. That's not log base 7. If I want to enter a log base 7, I have to hit the math button and scroll all the way down here to where it says log base, and then I can enter the base 7. Right? And you see the log base 7 of 49 equals 2, like we said. But you should, these are all set up to where you should be able to find these without the use of a calculator, right? So I'm only going to show you that one time, right, for that one question. Alright, next question. 8. What's the log base 4 of 1? Well, that would be 0, right? Since 4 to the 0 power is 1, and that works, right? But remember, the log is equal to an exponent. It's the exponent you'd raise this base to get the number inside. So the answer is 0. And if you were to enter this in a calculator, the log base 4 of 1, you would get 0, I promise you. Alright, number 9, what's the log base 16 of 4? And I'll tell you right now, this is the 1/2 power. Remember, the half power was square root, right? 16 to the 1/2, right? Since 16 to the 1/2 power, right? Remember, that's the same thing as the square root of 16, which is 4, right? That number inside the log. So that works. Now, the ones with the fractions like this might be tricky. So again, an alternate way to do this would be like I did number 7 earlier. Or I could have done it this way. We have the log base 16 of 4, and let's say say I don't know what this is, so I call it x again, right? And now I want to find x. So we change to exponential form, which would be 16 to the x power equals 4, and then both sides I can write in base 4. 16 is 4 squared, and then this is being raised to the x, right? 16 to the x equals 4 to the first is 4, and then power to a power rule. 4 squared to the x is 4 to the 2x power equals 4 to the first, and now I have both sides as the same base to a single power. Using the 1-to-1 property for exponential functions, 2x must be equal to 1, and then dividing by 2, x must be equal to a half, right? So the log base 16 of 4 must be a half, as I said earlier, right? Okay, and then here, number 10, right? Same deal. I can do it in a couple of different ways. One is just think about it. If you know your powers well enough, you should be able to state these pretty easily. The log base a half of 2, 1/2 to the negative 1 power would be 2. All right, so the answer is -1. But again, say you didn't know that. All right. Say you didn't know that. So let's try it the way I've been doing the other ones, right? Or we do the log base half of 2 equals I don't know. So I call it x. Then I change this to exponential form. 1/2 to the x power equals 2. And I can write both sides with base 2 pretty easily. 1/2, that's 2 to the -1. And then on the other side we have 2 to the 1. And this isn't a single power. I need to use that power to a power rule, multiply these. We have 2 to the -x equals 2 to the 1. So -x must be 1, and x must be -1, which is what we said already earlier, right? So the log base 1/2 of 2 is -1, right? Since, I should have written that earlier, right? Since 1/2 to the -1 power is +2. Great. Check on that. All right. And I got just a couple more of these. So number 11, exercise 174 from the text. We got the log base 2 of 1/16. Again, if you know your powers well enough, these should be pretty easy. We know that 2 to the 4th, right? 2 to the 4th is 16. So 2 to the -4 would be 1/16, right? The answer is -4. All right, again, since 2 to the -4 is 1/16. But once again, if you wanted to, say you didn't see that, say you don't recognize that, you have the log base 2 of 1/16, and you're trying to find this, so I call it x, right, or whatever you want, x, y, z. I change to exponential form. So that's 2 to the x equals, 1/16. But then, this, again, this should be easy. This is 2 to the -4th, so obviously x must be -4. I mean, you should know your powers. Powers of 2, powers of 3, powers of 4, whatever. Okay. All right, then finally, another, again, I feel simple one. All these should be pretty quick. What's the log base 4 of 1/16? Right, so 4 to what power would be 1/16? Well, you know that 4 to the second power would be 16. So 4 to the -2 would be 1/16. Remember, negative powers are the reciprocals of the positive ones. So the answer is -2. Right, and that's because, right, since 4 to the -2 is 1/16. And again, you could call it x and then say 4 to the x equals 1/16, but again, you should be able to write 1/16 as 4 to the -2 and see, this is -2. Right. Okay? And again, if you want to check these with some calculator, fine, but you should be able to evaluate the exercises here without one. Great. Just remember that logarithms are equal to powers, right? Logarithms are equal to exponents. What exponent do I need to raise the base to get the number inside the log? Great. Alright, so I'm hoping that watching me go through these 12 examples here help you in some way when you're asked to evaluate logarithms on your own. And thank you very much for watching.